Hello, I have finally got my little circuit here to subtract numbers using the adders that I was using before. And I'll show you how it works here. I'll just make it back to night here. So this is obviously an adder. I can do 5 and it will show me 5. I can do 5 on the bottom signal and it will show me 5. I can do 5 plus 5 and it will show me 10. 8 plus 2 is 10. Yep, there we go. So regular adder. So the question then becomes, how do you subtract in binary? And the key is that I need to invert one of my inputs. So those are my adders over there. I've just put XOR gates here only on my A inputs. Only on my A signal inputs. And I'll kind of explain how this works here. So we subtract numbers in binary by something called the 2's complement. 2's complement. And this is how it works. So let's say I have a signal of a 1, 0, 0, 0 in binary. That is a 1 in binary. This equals 1, right? If I was to invert this signal or take the complement of it, it would become 0, 1, 1, 1. I can do it with any binary number. I can do something like this. So a 0, 1, 0, 1, and if I was to invert it, it would become a 1, 0, 1, 0. So that's all it is. This is called the complement. This is the complement of that, and vice versa. It's just a complement. So let's see what happens if I take the complement, which is basically the inverse everything. So I'm going to hit this switch here. It's going to inverse everything. So now everything is on, right? And that's because this is feeding these XOR gates and activating all of my A input signals. So this is what it means. Instead of pressing 1 and this turning on, if I press 1, this will turn off now. If I do 2, I'll get 2 in binary to turn off. So now I've inversed my binary numbers, right? I can just count up in the on position or the off position. So let's see what happens if we quote unquote add these together. So if I do 6 plus let's do 4, gives me a 1. That's an interesting answer. But let's say because I'm inverting one of these signals, this bottom signal, there's actually subtraction. So 6 minus 4, I would expect 2, but it gave me a 1. Let's try another number. Let's try 10 minus 3, let's do 4. 10 minus 4. So I would expect 6, which would be these two on, but it's giving me 5. This plus that is 5. So I'm 1 short. Just with how the math works out when you add binary numbers like this together, you will be 1 short if you're minusing. Because all I'm doing instead of doing 10 plus 4, I'm doing 10 plus the inverse of 4. That's basically what I'm doing. So instead of 10 plus 4, I'm doing 10 plus negative 4. That's the goal here. But I'm always 1 short, right? So if I do plus 5, I would expect 10 minus 5 to be 3, but it's giving me 4. Sorry, I would expect 10 minus 5 not to equal 3. I would expect 10 minus 5 to equal 5, but it's giving me 4. So I'm always 1 short. So right now we're doing a 1's complement is how we're adding these numbers together. So if I was to connect this circuit right here, that means anytime I inverse my whole setup here, I'm also adding 1 to the input. I had to kind of adjust all this because this was originally a half adder and everything was built around there, so I had to kind of make some space. So now this is a full adder, so I can have a carry in. So on the carry in, I'm adding 1 here. And what that does is it turns this into a 2's complement. So now if I take 6 plus -6, it should give me 0. Let's say I do 9 plus -7. I would expect 2, so this one should turn on. Yeah. Do a big one. Let's do 15 plus a -8. So I would expect 7, 4, 5, 6, 7. And there we go. I can subtract in binary. Now there's a couple things that I'm still missing, because in theory I should be able to do a 6 minus a 7 and it will give me a -1. Right now it's not doing that. If I do a 6 minus a 7, I just get like error basically. I do 6 minus 8, it still does some weird stuff. Like, I don't understand what's going on here, so I need to troubleshoot this more. In theory, though, if I do, if my answer is a negative number, then this last bit is actually denoting the sign, if it's a positive or a negative number. If it's on, it should be a negative number. If it's off, it should be a positive number. So it works when I do a bigger number minus itself or a smaller number. You know, that one stays off because it's a positive number. But if I was to do smaller number minus a bigger number, I should get 1 here, and then that one would turn on. That would denote that it's a negative number. But right now, I don't know what's going on. I need to figure out what's going on there. But yeah, right now I can only, with how this is set up, I can take this one and I minus this one. So it will never be backwards. I can't do like, 8 minus 7. It's just not how it's set up. So as far as I understand, at least. So this one is my negative numbers. And again, that's just with the switch. So if I have my subtractor button off here, then I'm adding. 11 plus 11 is 22. Be 16 plus 4 is 20, plus 2 is 22. Then if I hit my minus sign, then 12 minus 11 should be 1. Pretty cool, pretty cool. So now I can add and subtract with some limitations, but I can add and subtract using this same adder. But I'm just adding a negative number. So the inverse of a binary number is the complement, is the 1's complement. If I take the inverse plus 1, then that's called 2's complement. So the theorem for this is called 2's complement in binary. Pretty interesting stuff. I thought I was going to have to build a whole other thing to subtract, but apparently not. And I've been reading how to get multiply and divide, and all you do is you shift all bits over to the left one to multiply by 2, or you can shift all bits over to the right one to divide by 2, because obviously this is a base 2 setup. So that will be interesting to discover as well, and to learn how to do. So there you go.